Welcome to This Explainer. Today we're diving straight into the foundational verbs of C programming. Think about it like this. If variables and data are the nouns of your code, operators are the verbs. They're the actions that actually get things done. We're going to transform what might look like dry, abstract syntax into a seriously powerful toolkit for problem solving. By the end of our time together, you're going to have a really firm grasp on the symbols that bring your code to life.
Here's how we're breaking it down today. First, we'll meet the C operators. Then, we'll look at doing math, making comparisons and decisions, using coding shortcuts and increments, and finally, we'll wrap up with advanced logic and bitwise operations. Let's get to it.
Section 1. Meet the C operators. These really are the fundamental building blocks of C.
So, what exactly is an operator? Put simply, they're the essential commands you give the compiler. When you arrange variables and constants together, you get an expression. But without operators, your data just sits there. It doesn't actually do anything. Operators are the tools you use in a program to actively manipulate that data.
The C language actually organizes these tools by what they do, their function. We've got arithmetic operators for crunching numbers, relational ones for comparing values, logical operators for handling complex conditions, and bitwise for getting right down to low-level data manipulation.
Moving on to Section 2. Doing math in C with arithmetic operators.
Let's map out the basics. Here, variables like a and b act as our operands, which is really just a fancy way of saying they're the data receiving the action. You've got your usual suspects: addition with a plus, subtraction with a minus, multiplication using an asterisk, and division with a forward slash. So if a is 10 and b is 20, a plus b evaluates to 30. It's essentially straightforward algebra translated directly into C.
Now, here's a C programming quirk that catches a lot of people off guard. Integer arithmetic always yields an integer. That means any fractional part, it gets entirely truncated, just chopped right off. But if you actually need a precise decimal number, you have to use what's known as mixed-mode arithmetic. For example, look at 15 divided by 10.0. Because we explicitly introduce that decimal into the mix, C knows to give us a real number, resulting in 1.5.
Alongside those standard symbols, you absolutely have to know the modulo operator, represented by the percent sign. Modulo performs a division, but it only hands you back the remainder. So dividing b by a with modulo just returns what's left over. But, and this is a critical limitation you need to memorize, modulo fundamentally rejects real numbers. You cannot use it with decimals. It is strictly an integer-only tool.
So what happens when we combine all this? Well, when C encounters an expression without parentheses, it reads from left to right, but it strictly obeys a hierarchy of priority, an order of precedence. Multiplication, division, and modulo sit right at the top. Addition and subtraction, they're down at the bottom. Take the equation x equals a minus b divided by 3 plus c times 2 minus 1. Even without parentheses to guide it, the compiler is going to hunt down that division and multiplication first before it even thinks about adding or subtracting.
All right, Section 3. Comparisons and decisions using relational operators.
Relational operators basically check if a specific condition between two operands is true or false. You have your standard greater than, less than, greater than or equal to, and less than or equal to. But keep an eye on the check for equality. It requires a double equal sign. And if you want to check if two values are not equal, you use an exclamation point followed by an equal sign. Whenever an expression contains one of these, we call it a relational expression.
Here's the really crucial point, though. Relational expressions do not return the actual text true or false. They evaluate strictly to a binary truth value of either 0 or 1. So if a is 10 and b is 20, asking if a is greater than b will mathematically evaluate to a 0, which is exactly how C represents false.
There are some strict boundaries on what you can actually compare, though. The operands of a relational operator must evaluate to a number. Now, single characters are perfectly fine because, under the hood, computers just read characters as numeric values anyway. But whatever you do, do not fall into the trap of trying to compare full text strings this way. Never use these operators to compare a string like hello to a string like bye. These operators are built for numeric evaluation, typically used inside decision statements like if blocks or while loops.
And just like with our math operators, if you want to avoid some really frustrating logic bugs, it is absolutely essential to memorize this top-to-bottom ladder of precedence. At the very top, the logical not operator, that's the exclamation point, has the absolute highest precedence. Below that are your standard greater or less than comparisons, followed by equality checks.
Dropping down again, we find the logical AND operator, which is 2 ampersands. And sitting way down at the lowest priority is the logical OR, represented by 2 vertical pipes. Trust me, if you don't memorize this hierarchy, your compound decision loops are going to evaluate in ways you completely didn't intend.
Moving on to Section 4, Shortcuts and Increments, or How to Write Code Faster.
C actually offers a really elegant set of shorthand assignment operators. Instead of writing out a long-winded variable equals variable plus an expression, you can condense the whole thing right at the variable level. By using a compound operator like plus equals, you just write v plus equals exp. It does the exact same thing as v equals v plus exp, but it is so much faster to type and honestly a lot easier to read. And yet, you can do the exact same trick with minus equals, multiply equals, you name it.
Then we have the increment operators. You're going to use these constantly in loops like for and while. But pay super close attention to the order of operations here, because this is exactly where bugs love to hide. You can put the plus plus either after the variable, which is called post-increment, or before it, called pre-increment. Now, if you write y equals m plus plus, that post-increment uses the old value of m to assign to y first, and then it increments m. But if you use pre-increment, writing y equals plus plus m, the variable gets incremented first, and then the expression is evaluated using that brand new value. It seems like a tiny subtle difference, but I promise you it completely changes the outcome of your expression.
Finally, Section 5, Advanced Logic and Bitwise Operations for that low-level control.
First up in our advanced toolkit is the conditional operator. Think of this as a highly compact decision maker that basically condenses an entire if-else block into a single line of code. It looks at the first expression. If expression 1 is true, it evaluates and returns expression 2. If it's false, it just skips right to expression 3. Take a look at the example. X equals the condition. Is A greater than B? Followed by a question mark. If yes, assign A to X. If no, which is indicated by the colon, assign B to X. It is an incredibly efficient little tool.
And taking it way down to the machine level, we have bitwise operators. We use these for testing or literally shifting raw binary bits left and right. When you need extreme high-performance control over hardware or things like data compression, this is exactly what you reach for. However, because they rely entirely on exact binary representation, they strictly forbid any interaction with floating point decimals or double data types. They are strictly for integer-level bit manipulation, period.
Wow, we've covered a lot of ground today, navigating from simple addition all the way down to shifting raw bits at the machine level. So now that you understand the grammatical verbs of the C language, the only question left is this: how are you going to combine these operators to build your own logic? From basic arithmetic to raw bit manipulation, which operator will form the foundation of your very first C program? Thanks for joining me on this explainer, and happy coding!